Here's an explanation of motor breaker sizing and common issues encountered during electrical inspections. Let's break down the calculations and identify the potential problems. First, the wire sizing. According to the National Electrical Code, the wire size should be calculated using a formula that accounts for the total load and the contribution of other motors. The wire size is equal to the total load in amps, multiplied by 1.25 plus the running load of other motors in amps. In your situation, with two motors each pulling 36 amps, the calculation is 36 amps times 1.25 plus 36 amps, which equals 81 amps. Using this calculation, number 4 wire is adequately sized. Now, let's consider breaker sizing. The breaker size is determined by multiplying the motor's full load current, which we will call full load current, by the motor overcurrent protective device multiplier. The overcurrent protective device multiplier is typically 2.5 for motors. So, in your case, 36 amps times 2.5 plus 36 amps equals 126 amps. A 150 amp breaker would be appropriately sized based on this calculation. One critical factor that can cause tripping is inrush current. Motors draw a very high surge of current when they start. This is known as the inrush current, and it can be several times the motor's rated full load current. The 90 amp breaker that was installed is likely not sufficient to handle the combined inrush current of both motors, which is why it is tripping. The inspector's suggestion to upgrade to number 2 wire because of ambient temperature derating is not necessarily relevant to the tripping issue itself. Temperature derating is considered to prevent overheating of the conductors, but the immediate tripping problem usually stems from the breaker's inability to handle the inrush current. In summary, based on the calculations, the number 4 wire is appropriately sized for the running load, and the originally specified 150 amp breaker is also suitably sized to handle the motor's overcurrent protection while allowing for inrush. To resolve the issues, consider these steps. 1. Replace the 90 amp breaker with the originally calculated 150 amp breaker. 2. Conduct a thorough check of the wiring for any potential shorts or loose connections. A megger, which is an insulation resistance tester, should be used for this purpose to verify insulation integrity. 3. If the problem persists even with the correct breaker size, further investigation may be warranted. This could involve checking the motors themselves for winding faults or other issues, or inspecting the power supply to ensure it can adequately deliver the necessary current during motor startup.